We have a lot of around 200 members who are not active, but 200 members are already there working in various metros in India and across the Middle East and other regions also. So I just thought we can expand our region by getting more and more members from the Indian PWI community, and thus widening our base here. And the idea is only for sharing the best practices. We work for a lot of other countries, so we can always share the best practices. So this is the platform I thought, and from here we go. Yes, over to you.
Thank you, Mr. Nagesh and Vibha Rao and all others. First of all, I am very thankful to the Permanent Way Institute. I think this is a branch of uh, Permanent Way Institution of London. That's what I had. Thank you for inviting me to this event. And I had every month they select a speaker and they conduct an event. So in this year, I will be the last speaker. So the structure of my presentation will be something like this. Since I came from Indian Railways, I will talk few minutes about Indian Railway, then about the track in metro, then again about the Chennai Metro itself. The Chennai Metro Phase 2 is one of the largest project ever undertaken at a single time. And we have a lot of challenges and all. So we can see the challenges during the course of the presentation. First of all, the Indian Railway is the second largest rail network with more than 68,000 route kilometer and also more than 1,03,000 running kilometer. And Indian Railway has many PSUs like RITES, IRCON, RVNL, this you may be knowing, and many other companies. Apart from that, recently, about more than a decade ago, dedicated freight corporation has been started. Previously, India, even now, Indian Railway is having a mixed traffic. That is passenger traffic and also goods traffic. This passenger traffic takes a lot of time. For example, if you start from Chennai to Delhi, it takes more than nearly 30 hours, just 2,000 kilometers. So every country is expediting their infrastructure, increasing the speed. And the dedicated freight corridor, they want to transport all the goods and goods from different part of the country, connecting the vast eastern corridor to western corridor and south to north.
Hello.
My audible, Nagesh?
Yes, very much.
Ah.
Very
Yes,
much.
yes, sir.
Audible. Once this dedicated freight corridor is meant only for goods, that is transportation of goods, the huge relief will be there for the passengers. That is one part. And secondly, this dedicated freight corridor will be a game changer with more than 8,000 kilometer, 8,000 kilometer running across all vital ports and interior capital cities. Already out of 8,300, 50% of the work has been completed and commissioned. This will be a game changer for logistic industry. For example, out of this entire our rail traffic, 70% of rail traffic like container is from Mumbai to Delhi. So that corridor they completed first. This is for the information of you because you should know about the Indian situation and how the rail industry, it is a lifeline of India as far as passenger is concerned. And now this rail industry through DFCL, they are going to transport a large amount of goods from the ports to the interior of the city and vice versa. Other than that, in the rail industry, we do not have any high-speed rail. Almost all the developing countries and even China has already in far ahead of us in high-speed traffic rails. High-speed means by definition it is about 225 kilometers per hour. If any train goes more than 225, it is called high speed. And 150 to 225 is called semi-high speed. We neither have high speed nor semi high speed at present. Our average speed of the passenger train is less than 100. That's what I told. 2,000 kilometers from Chennai to Delhi, it takes more than 30 hours or 28 to 30 hours. So it means it is less than 100 kilometers. So in the present scenario of information technology and this one, we cannot afford to run with the old speed. So railway decided to first make it up to 150 km plus certain stretches. Then subsequently, they started National High Speed Railway Corporation. This National High Speed Railway Corporation is mandated to connect major cities like Mumbai, Ahmedabad, Delhi, Varanasi, Howrah, then Chennai, Mysore, and so on. They selected 9-8 location that will travel more than 450 to 500 kilometers. Definitely, the speed will be more than 300. That will be high speed. So once high speed comes, lot of smaller, say Chennai to Bangalore, then Bangalore to Hyderabad, lot of traveling time, detention time between this airports that will reduce. For example, Chennai to Bangalore, the flying time is only 35 minutes. But we travel to the airport 1 hour, again and 1 hour, and security time more. It takes more than 5.5 to 6 hours for Bangalore. So if high speed comes even at the rate of 30 km, which 300 kilometer, Bangalore is exactly 350 kilometer from Chennai. It will take maximum 2 hours. So such situations are there and locations, possibilities are throughout India. Chennai to Bangalore, Chennai to Mysore, Madurai to Coimbatore, and Chennai to Hyderabad, and so on. Lucknow to Delhi, Jaipur to many places are there. They need not go by flights and huge cost, and this will be a time saving. There was another major aspect is that we have a huge potential in the form of national high speed rail. High speed rail. Apart from that, various companies like RVNL and IRCON and RITES, these companies under railways are working with some nominated, some with mandate. Now the Indian Railways have liberalized. They have to work like a private companies. This is a recent phenomena. So they are participating and taking the work, and they are executing like a contractor. This is the recent policy done by government of India. So in short, I can say India has a huge potential for rail industry, and it is growing. There is railway financial or institution is there in IRFC, Indian Railway Financial Corporation. And many things are coming up in and around rail. And in the process, in case of cities, we do not have a good transport system. In the last 2 decades, huge number of population is moving from rural to urban for want of job opportunities, and also the agricultural this insecurity. People are moving to cities. You know, Delhi population is now more than 3 crore. It is more than a Kerala population. Delhi is growing like that. And whether the metro is there or traffic is there, they are simply growing. And in case of Chennai, for example, where we are here, every 10 years, 20 lakh population is getting added. 20 lakh means it is in Tamil Nadu, we have Madurai and Coimbatore, that population itself is 15 lakh only. So every 10 years, either Madurai or Coimbatore is getting added to Chennai. How to solve this problem? This happens in every city now. Mumbai, Delhi. So we need to augment many city infrastructures like water supply, sewerage, and parking spaces and entertainment spaces. Many of the infrastructure facilities we have to augment to meet the unprecedented urbanization. In this context, what we need is mobility first. The mobility, assured mobility and large scale mobility. So in this context only, metro becomes very important. This way, Delhi Metro started about 15 to 17 years back. And when Delhi Metro became successful, then they started in Bangalore, closely followed by Chennai. So metro is catching up now. More than 50 cities have been identified. Works are going on. So this way, the metro is found to be the one of the single important decision for the urbanization. That is a traffic solution. Metros are not viable according to this one capital intensive project, and we have financial problems, and various banks are helping us to make it construct the infrastructure. But even though capital intensive not viable, operationally we are able to make viable, and we are able to solve the problem of urbanization and ensure mobility. Okay, with this talk, and I will go through the slides, and you can get the feel of Chennai Metro. This phase, especially phase 2. This is the vision statement of Chennai Metro: moving the people and sustaining the growth. This is normal to every company, and mobility is the most important part of our metro, Chennai Metro. And this I talked about rail industries, metro rail, suburban rail, dedicated freight corridor. This regional rapid transit system you may be knowing, the RRTS we call. RRTS is close to metro, but the speed will be more than 100 km/h. And the stations will be placed about 5 kilometers, 6 kilometers. The RRTS is being successful now at Delhi Capital Region, you may be knowing. It is connecting different direction, Meerut, Jaipur, all different direction. It is connecting people of different states. It is metro concept, mostly elevated underground, but the speed will be more and the stations will be less. The metro rail system. Our metro rail is under the Ministry of Urban Development, and we use only standard gauge. And initially, Delhi Calcutta Metro started in 80s, 87 and all. Then subsequently, Delhi Metro used broad gauge, but now we made standard gauge as the gauge for metro. We have ballasted track and also ballast not ballasted depots in metros. Chennai Metro is the only metro in India which has ballastless depot. That the photo is not available, but we have ballastless depot in phase 1 also. In phase 2 also we are developing ballastless depot. This is about the ballastless track normally adopted in all metros in case of elevated track. Our track structures are governed by RDSO. Even though we are under the Ministry of Housing and Urban, that still we depend upon RDSO for technical specification. The Ministry of Housing and Urban Affairs do not have a technical body. So we depend upon Railway Board and this one for technical approvals. Balance everything is execution is done by respective metros. This is the UAG 60 profile we use. We use head-hardened rail. In railway also they use the same profile, but we use fully head-hardened rail because of sharp curves. In metro environment, the alignment are with 120, where sharpest radius is 120 meter, and most of the radius, 40% of the length is between 120 radius to 300 meter radius. Such a sharp radius is not this one allowed in broad gauge. But in metro, we have no other way because of built up area, we are doing the viaducts. So we are necessarily, we have to use head-hardened rail. Otherwise, the head will be worn out. So at present, we are still few years back, we are importing this rail. Recently, Jindal is able to supply, and we Chennai Metro, other metro start using Indian head-hardened rail. Otherwise, we used to import from France and Australia. Even Indian Railway also used to import. The head-hardened rails were not available in India. These are the codal provision. Just for the information, we have IRS T12 2009. We follow this code only for procurement of railway head-hardened rails. Recently, we inspected this factory, the Jindal Steel plant, for procurement of these rails. We use this double resilient base plate with E-clips. Even Indian Railway use this same standard. You can see this turnouts. This turnouts only difference in metro compared to Indian Railways is we make custom-made turnouts based on the site condition. We take the measurement, we order accordingly, and the entire thing is welded. Here they show welding, but we don't have any welded this plated joint. Whole thing is custom made. This is welding technology. The other difficulties are working in tunnels compared to elevated. Track work in tunnels are very difficult, and because every welding machine, we have very small opening through the underground station. From there, we have to drag the rail inside the tunnel. There, we have to unload the welding machine, and we have to do welding inside. You can assume how difficult it is to weld inside the tunnel, and the working condition will be very tough. There will be a lack of oxygen and humidity will be there, and a lot of sweating will be there. We have to ensure fresh air, and all the facilities we have to make so that labor will work. And we cannot make long welded rails outside because the space we cannot lower it. You can see the track work inside the tunnel. And one more difficulty is every 3 to 4 station, so 3 to 4 kilometer, each kilometer one station is there. Every 3 to 4 kilometer only we leave the opening for rail. So they have to drag inside the tunnel nearly 1.5 kilometer either side. This is unavoidable because if we leave the opening everywhere, then we cannot we cannot complete the station also. These are the difficulties in executing track work inside the tunnel. And the concrete has to be pumped for long length. The concrete develops segregation, and pumps do not work. This is the other difficulty. Pumping has to be done from the top. You think about sending the concrete inside, how much should be the pumping pressure and all. Then we use all kind of vibrational mitigation measures wherever commercial things are there and hospitals are there. The hospitals sensitive instruments are there. We, as per the codal provision, we have to reduce the vibration. Otherwise, that instrument will get affected, and the measurement of the instrument will not be good. So there is a health hazard. So we use a lot of vibration mitigation track. Again, we like Indian Railway, we do rail grinding. Recently also we have done rail grinding. Because of the sharp curves, rail develop corrugations. So we have to frequently, once in a year or 1.5 years, we have to do rail grinding to smoothen the surface. This is about the just now I told about track. This is about the phase 1 project which has completed under operation, and again it is about phase 2. In phase 1 we have 54 kilometer of track, out of which 27 kilometers elevated, about 26 kilometers underground with the 41 stations. Our ridership was very less last few years back. Now we have gone up to 3 lakh. You can see 3 lakh per day roughly. Sometimes it will be there. Each month about 85 lakh. This is the August figure. It was August 1 year back. It was only 56 lakh. In February it became 63 lakh. So daily ridership is about 3. It crosses 3 lakh, but average is about 3 lakh. Saturday, Sunday it will be less. This is the prestigious phase 2 work. You can see the green and blue. This is phase 1. The other 3 corridors we call purple corridor, orange corridor, and red corridor. Another 3 corridor put together, we are constructing about 116 kilometer and 118 stations. You can see the portion of the elevated and underground. And we are using nearly 23 tunnel boring machines in the phase 2. This is one of the largest. In India, nobody used 23. Somewhere in they say Russian people used 23 numbers. And this is that is why I call this is the largest project taken up at a time. The cost of the project is 63,000 crore. These are the funding agencies. Major funding agency is JICA, that is Japanese International Agency, funding agency. Then AAB based at Beijing, and ADB, NDB, they are the multilateral agencies. JICA is bilateral agency. The balance is from Government of India and Government of Tamil Nadu. The main challenges of metro construction is first is the land acquisition. First is the land acquisition. So without land acquisition, we cannot do utilities and traffic management. Inside the city, particularly in Chennai, we have only a 16 to 17 meter, many places 10 meter road also we have. So to construct a pillar, we need 8 to 9 meter pile and pile cap, 8 to 9 meter. If you take away 8 to 9 meter, there will not be any space for road traffic. So first we have to acquire the land to divert the traffic. Second, once divert the traffic, we have to find the utilities. Then only we can start the work. And there are different utilities, so very many stakeholders are involved. So these 4 items are most challenging one. I will see when we go through, we can see the challenges. Already we have acquired the land, about 95%. You can see the road, it is small road, and it existing road is only 10.5. We widened 24 meter. So we already widened, we demolished this old photo. You see, think about how much we should have demolished all these buildings and a lot of court cases. Many issues are there in the land acquisition, but it took more than 1.5 years to acquire this land. Unfortunately, after awarding the contract, we acquired the land, this particular location, so project got delayed. And utilities. Since we adopt OHE, overhead traction, these kind of utilities are crossing everywhere, many places, more than 12 locations such crossings are there. And we have spent more than 500 crore to lower this overhead heavy tractions. Otherwise, it will interfere with our overhead traction. This is a major challenge, getting approval and make it underground. Then only we can do the piling. Otherwise, the piling itself, the induction will come. So this is the major challenge. We are able to overcome everything except one place. Still one place we are not able to do. These are the utilities. One of the station only I am projecting, Prasavakam. You can see the utilities. These utilities are exactly below the diaphragm wall. This is underground station. You can see the station. Blue dotted line is the diaphragm wall. When we excavate the diaphragm wall, this much utilities we have found. You think about diverting it. Diverting this utilities, separate land location is required. Unfortunately, we don't have land there because it is built up area. We need few meters. So we that few meters, if we acquire large scale, the multi-story buildings are getting affected. So what we have done last 1.5 years, we shifted within the station itself. That station width is about 30 meter. Within the station itself, we shifted one side, then we have done diaphragm wall, then again we have shifted like that. 2 round of shifting we have done. About 90% of the work completed last 2 years without land acquisition, because once we go for land acquisition, huge buildings have to be demolished. And partial demolition is very difficult and we have to acquire full building. So we have adopted this method. There are many locations like that, traffic junctions and all, posing lot of problem for utility shifting. You see, we will shift to one side and we will shift again another side. Then stakeholder meeting. There are some 20 stakeholders are there. Very difficult to get the approval from the stakeholders for any utility because it is not their baby. We have to do the project. And at the chief secretary level, we have a high power meeting every 2 months. That is mandatory for land and other issue. So that way state government is helping us to overcome the difficulties to execute the project in the urban environment. This next is the challenges in construction part. I cited here only few challenges, some 4 numbers in elevated and underground, but the design and construction of phase 2 is very challenging. Everything will take time. I will few the location around I will highlight. You can see the elevated 4 numbers, underground 2 numbers. Majors this one. This is the first challenge in elevated. Corridor 3 and corridor we are connecting, we are linking with the existing highway people. They want to construct a flyover. When they construct a flyover and we also construct, it will take time and they have to again start late and it will be a problem for traffic, passengers, commuters. So they have to start the flyover later and we want to start early. Then after repeated meeting, both we have clubbed. Now we are executing 2-lane flyover and 4-lane flyover. That is in single column, 4-lane flyover, 2-lane on each side. Then metro, we are running on the top. Nearly 4 locations we are doing like this. So this is challenging because the lot of precast elements are there, not visible in this drawing. There is a big challenge in execution. Each segment is having 7 precast element, each that's beam you can see. So stitching each one and doing pre-stressing of each one and again final pre-stressing, and then only we can construct concourse. Another challenging location was this is the famous one Kathipara flyover in Chennai. This flyover is of 2-level height with clover leaf, and the same flyover in the phase 1. I was working in the phase 1 also. This corridor blue and green, 2 corridor we constructed. The blue is the lower one and the green is higher one. So already the flyover is 2-level and we have constructed another 2-level. Now one more 5th level we are constructing this corridor 5. This red is the proposed one. Work is under construction. So again, this is most challenging in the sense it is a construction methodology and without disturbing the traffic below. both road and our own corridors, we are executing this work. So this is the again construction challenge, and we have to ensure the safety of the commuters and passengers below the our corridor. And this balanced cantilever is of 120-meter radius sharp curve. That is the sharpest curve, and it is about 480-meter length. Nowhere they have done in India this much length. Foreigners would they would have done, but in India 480-meter length and sharp curve nowhere they have done. So that is a challenge, both the design and construction wise. This is another location in corridor 4. I will show you. You can look at this. This is 2 corridor, one above other we are constructing. Both are same. This one only. You see this corridor. Bottommost is the concourse. This is the one single column. This is below ground level. One single column. Bottommost is the concourse. Again corridor 4. Again corridor 5. We are constructing. So 2 corridor and also concourse, all in single column. Nowhere in India they have done this type of design, but because of site condition, we have taken this way. Otherwise, 2 corridor we have to acquire separate land acquisition. A huge demolition will come. So to avoid land acquisition and building demolition, we have taken 1 corridor over another, and we have overcome the problem. But it is a big challenge to all are precast, and we are constructing with. You can see now you can see this one. This launching corridor was fabricated in China. So with this corridor, first we are doing the bottommost corridor, then top corridor. Whenever station comes, concourse also will add to the this one pillar. So the pillar, single pillar takes 2 corridor plus concourse. This again, you can see the inside small 3 trains are there. One of the location we have no land because existing elevated, again we are putting that orange color portal, and we are taking the phase 2. Bottom is phase 1. This is near Coimbatore. So encasing the phase 1 through this one, what you call portal, we are constructing a new corridor. Without affecting the existing running track, we are designing and executing. Again, in case of one of the underground stations, 2 corridor is crossing. The peculiarity of this station is one side there is a stacked tunnel. This is Mylapore station. One side, this is the 2 corridors are merging here. One is corridor 4 and another is corridor 3. You can forget about the corridor. What happens is we are crossing 2 sets of lines, 2 lines. One side there is no road width, so we are coming as a stacked tunnel, one above other. And while approaching this station, we make it parallel. It comes one above the other from one side. That is from lighthouse side, we get beach side. Then when coming to this particular station, it becomes parallel. The other corridor, it comes parallel. While coming to this area, because of land and road width only, we make it stacked. So there will be 4 tunnel and 4 levels, bottommost top concourse, then 2 tunnels, 1 tunnel at the top, 2 tunnel, then bottom. So it is almost a 5-level station, about 34-meter depth, and also we find rock in below 25 to 26 meter. So you think about the difficulties in execution of this station. One more location, this is RK Salai. Again, this slight green color, that is the existing flyover. Exactly over the flyover, we are constructing the station. So we remove the flyover, completely demolish and remove the station. We are constructing the station. You can see the train standing, underground station. Again, that flyover will be reconstructed. So we are designing the roof slab of the station such that it takes care of the whole flyover load also. This is again Adayar Junction. You can see the red color and blue color, violet color. Our station is going cutting across the flyover. So we are demolishing before demolishing the flyover, we are constructing the red portion. Then part of the station we do, then remaining part without affecting the traffic. We divert one side, then they construct the other side the station. Like that, we are planning this. This is a busy flyover. So we have no land except this place. So we are constructing by demolishing, but without affecting the existing traffic. Now the project part is over. This is sustainability and the environmental things. We use solar, this one power. Nearly 17 to 80% of our power generated is from solar, and we want to increase to 35 to 40%. And every tree cut, one tree cut, we are planting 12 trees. So already some 30,000 trees we planted. They say each tree gives reduce the carbon dioxide by 21 kg. So this is our green, this one. And also the important trees, some heritage trees, some exotic trees and all, we are transplanting also. You can see the transplanted tree and how it has come up, how it is growing. This one particular tree. Some environmental activists, all they have gone to court. So they did not give this land. So we promised them we will transplant and make it survive. So we ensure that tree is surviving. You can see the green color. This is the transplanted tree. Again, this green aspect, we are using GGBS, granulated ground blast furnace slag. Usage of this one reduces cement content. It is alternative to the cement. So when we use this one, we are able to reduce the cement to that extent. The carbon dioxide emission also we are reducing. This is a major this one, except precast element, all the pile cap, all the diaphragm wall, huge diaphragm wall. We are doing nearly some 17,000 piles. It is a large project, and 15,000 meter of diaphragm wall. We call D wall. So all this we are using GGPS. But in case of PSC, we are precast element. We are not using GGPS. We are using cement only. So with this, we are able to reduce carbon emission. These are other green, this one, e-rickshaws. These are various measures, smaller measures to reduce the paper and reduce cutting of trees. You can see many awards we got because of our green initiative. Recently also we got platinum rating of all stations and a green champion award. And from London and also from Miami, we got international level also we got award for our green initiatives. And apart from Chennai Metro, we are already this one submitted a detailed project report for Madurai Metro and Coimbatore Metro. Madurai is about 34 kilometer, and Coimbatore is again about 30 kilometer. And other smaller cities like Tiruchirappalli, this one also we studied, but Madurai Metro and Coimbatore Metro, there is a feasibility. And the same Chennai also we are extending 83 kilometer, we are going to extend apart from this 116 kilometer. These are the upcoming project. With this, I will be completing. Thank you for the opportunity. I hope you would learn something about metros and the challenges. I wish the Permanent Way Institute all the success. And again, I thank on behalf of Chennai Metro, the organizers. Thank you. Thank you very much.
Yeah.
Any
Okay,
Thank you,
question,
sir.
anything you can
Yeah.
ask. I'm available for another 10-15 minutes.
yes. Yeah.
Yeah. If anybody is having any questions, either please raise your hands or you can put it in the chat box. Yeah, I could see Uday. You can ask the question. Yeah.
Yeah, thank you. Thank you.
Yeah.
Thank you, sir, for your wonderful insights on Indian Metro Railways and particularly Chennai Metro. Thank you for that. My question is, in one of your slide, you mentioned that population of Chennai is increasing, but
Yeah.
why the ridership is getting affected in spite of there being a demand?
Yeah, you are correct. Actually, the same we are running some 54. We have 54 coaches of train, four car coach since the beginning. But since ridership was less during the initial stages, we failed to procure the additional coaches. So with the 54 coaches itself, we are able to bring from 1.5 lakh to now 3 lakh. Now what is the problem is we don't have coach. So we are going to procure another 200 coaches. JICA, that is Japanese, have agreed for the loan. So once we procure 200 coaches, then 50 trains will be available. Once we put more coaches, definitely we will reach within immediately we will reach 5 lakh plus 5.5 lakh, 6 lakh with the same 54 kilometer. And
Okay, sir.
these two corridor only we are running. One of the corridor is almost along the main road and also suburban traffic is there. The present three corridor that is totally a different. It is going to a central business district area. There is no suburban traffic, no proper roads are there. So our ridership will definitely increase.
Okay, sir. Thank you, sir. Thank you for your answer. One more follow-up question, sir.
Yeah, please.
Regarding ballastless depot in Chennai, so constructing ballastless depot means a lot of cost involvement.
Yeah,
So was the flooding prone region being the main reason, or there was any other factor for going ballastless depot?
So actually, original this in phase one, we have gone for ballastless for to maintain a good quality track only. But what you said is also correct. We want to maintain the track parameter. We thought ballast with the ballast track parameter will be difficult to maintain. Dust will be the issue. But in our phase one, the Coimbatore depot, it was a pond actually. That pond with clay of up to 120 meter, 20 meter depth. So first 5 meter we have removed, then balance this one we have vertical drains we installed and removed the water and consolidated for 1 year. Then over that we have put different layers of muram and HBL, and finally we have done the ballastless track. Originally we wanted to do with this one only ballast, but we wanted to do a track for which we can return, but this location was a water stagnant area. In the last 5 years, 3 times this one was submerged. This particular depot. Every time it 1 or 2 feet above rail level. But now also they recently 1 week back the rain has come. No, 2 week back. Again this depot got submerged. But once water is withdrawn, we are able to retain the track. It is very clean.
Okay.
And it is a DIN code. We used German specification, and we have done this track, and it no track problem at all.
Okay.
Track parameters are intact.
Okay.
Even I executed. I doubted some subsidence will happen, some disturbance. Fortunately, after removal of water pumping out, track parameters are intact.
Thank you, sir. Thank you for your response.
Yes.
Yeah. Thank you, sir. Next one is Nishant Muniswamy. Please go ahead.
Good evening, sir. Thanks for the very insightful presentation. So I had a doubt regarding the stacked station, what we are having in Tirumale Vayil and that corridor, because I
I'm
was
gonna
there
tell
with the CML Phase 2 designs during that time when Spa pitched this idea, because if I'm not wrong, that was the first time we are going for a stacked tunnel in Indian metros. So as the construction started, was there any
you.
challenge? Because I was very curious how the tunnel boring will be performed in two different stacks.
Yeah. Now this method is being followed in Delhi Metro also. You know, the basic reason is road width is less. Particularly, we call one Kacheri road. The width is only 8 meter. We could acquire only 10 meter only. Now the station width instead of 22 meter, only 10 meter. So already we have constructed the diaphragm wall. We have launched the tunnel boring machine also. Only thing is the first tunnel should be at the bottom. Bottom tunnel should be bored first, so that we can comfortably do the second tunnel. That much is the precautions required. The problem is the road width is so less and placing the trench gutter and other machineries, bentonite tanks and all is a big issue. So this another problem is the stagger tunnel increases the depth. That is obviously. So the increasing depth creates problem because of excavation and rock and other issues. And it is not a good actually in the sense because there's a 10 meter how it will be. You see the concourse will be at the top, again tunnel, again another one mechanical level for all the rooms, again one more tunnel. So it is not a good design. And this all we do because of this land issue. That buildings and temples are there, mosques are there, and these people want that place. So that is why.
So would there be speed restrictions, sir, if the trains are running?
No,
or
no,
would it
no
run in
speed
the-
restriction. No speed
Okay.
restriction. It is a normal. Other things are normal. Only the tunnel has to be, since it is not parallel, bottom tunnel is executed first, top tunnel we can do later. And in the junction point also, some issues will be there that we have to take care. The two stations merging in the Tirumale.
Thank you.
And
Thank you,
not
sir.
only one station, we have some 4 stations like that.
Yeah.
All VIP area, we are not able to acquire the land. And we cannot make it elevated also. Yeah.
Thank you, sir.
Yeah, thank you, sir. Next one, Sai Teja, please.
Yeah. Good evening, sir. Good evening, all.
Yeah, good evening.
Thank you for the wonderful presentation, sir. I have a couple of questions.
Yeah, please.
So the first one is like, I would like to know who is the supplier or manufacturer of the fastening system and the turnouts.
Okay.
Yeah. And
This turnouts is, in fact, Waslow 5.
okay.
Uh.
Okay, sir. And the second one, sir, in one of your slides, you have mentioned that there is an infringement to the metro OLE with the BSNL tower and some other electrical lines.
Correct.
So is there anything that is restricting from using the third rail, like how what they are using in BMRCL, so that could maybe avoid the infringement?
Yes. Third rail will be a better system. Madurai and Coimbatore, we are proposing third rail only. But somehow we have selected in the phase 1 OHE. Again, phase 2, we are going with the same system. There is no other big reason, but technical reason they say is when we increase more coaches, they say OHE is, that is overhead equipment, is better than third rail. This I am not very sure, but given 3 coach, 4 coach, both systems are okay. When we increase to 6 coach, Delhi Metro and all doing 6 coach, 8 coach like that. When we increase, they say this OH is better. Otherwise, third rail is comfortable. I was director Kochi Metro. Third rail is good. This all this overhead problem can be solved whenever there is a crossing between 2 lines. Now we are crossing elevated over elevated. If it is third rail, the height will be less because of this OHE overhead equipment. Where height is increasing. Lot of disadvantages there. It spoils the cityscape also. But somehow we are going with this OHE because originally we have gone with OHE. The only justification is when more load is there, this one they are selling it advantages. Otherwise, third rail is good, better.
Yes, sir. Got it. Thank you, sir.
Yeah, thank you, sir. I think it's over. Questions are over. If anybody is there, please. I think this presentation is clear. Thank you, sir. Thank you for this your valuable time and this informations.
Thank you, Ma. Thank you so much for all the audience, and I wish a happy New Year to all of them. You told many of
same,
people
sir,
have
yeah.
gone for this one already in holiday mood. Okay. Okay.
Yes, sir. Yeah, yeah.
All the best.